Great. Good morning, good afternoon, good evening. Welcome to the Career Talk today. We are joined by three legendary water professionals, Earl, Steve, and Tom, and we can get started. So Earl, you're a Senior Vice President of the Water Group at Mott MacDonald with over 32 years of experience in planning, design, permitting, and construction of potable water around the United States. And you have expertise in design of surface and groundwater supplies, treatment, transmission, pumping, storage facilities, and have been one of the early adopters of water modeling software since the early 1990s. What are some of your career highlights?
Okay, can everybody hear me?
Yes, loud and clear.
Good to see you, Shar. Some of my career highlights. Well, like you said, Shar, I've been doing this for 30 years, or more than that, and started out in construction industry with Turner Construction, and I moved to a company in Millburn, New Jersey called Killam Associates, and we were environmental engineering consultants. And when I walked in the door in 1990, I started doing hydraulic modeling on mainframe computers. And I really enjoyed it. And at that time, modeling was moving to the PC, and GIS was gaining traction around the world. And I'd say my first real career highlight was building up that part of our business into a pretty good business that we ran in the Northeast and particularly in New Jersey. So in the consulting field, finding areas to work in and grow the business are definitely good for your career path and being successful. Then more recently, one of the things I worked on and we got published in ASCE magazine was working with a large water treatment plant here in New Jersey, and they were spending a lot of money pumping water into their treatment plant. But we looked at the area, and we realized we could get a lot more water from the reservoir into the treatment plant by gravity if we invested in some pipes. So we did some calculations, and we were able to reduce their carbon footprint quite a bit. If you're moving 50 million gallons of water a day and pumping it, that could be very expensive. And the ability to do that by gravity 2/3 of the year ended up saving them a lot of money. So that was another recent career highlight.
That's fantastic. Well, thank you, Earl. Moving on to Steve. Steve, you had a 35-year career in planning, design, construction, operation, management of both water and wastewater systems. And you've held positions such as VP of Engineering, Planning Manager, Director of Maintenance Services, and Director of Best Operating Practices. And you also volunteer often as a guest lecturer and trainer. So can you share a few highlights from your career journey, please?
Sure can, Shar. Hello, everyone. So I've had a really challenging and exciting career that allowed me to plan, design, construct pretty much everything from treatment plants to water distribution systems, and really the same counterparts on the wastewater side as well, from collection systems all the way back to treatment plants as well. The part of my career that really became interesting was that I spent a lot of time in engineering, but I also spent a number of years on 2 or 3 different occasions in the operations side of the business, both in the hands-on operation. I ran a water system in Connecticut and managed that operation for about 4 years. And we were bringing online several new large filtration plants. And then I also went back into operations at a later point in my career. And that's when I worked on best operating practices and worked with operations throughout American water systems throughout the United States. And the interesting thing is that, both my work with 2 major consulting firms, as well as to large water wastewater utilities is that, both types of those experiences were very valuable and were complementary and really helped me build a very broad set of experience, yet be able to specialize in certain areas like hydraulics and modeling and some other things as well, similar to what Earl was talking about. But the operations experience really made me a better engineer because I got to see and understand the results of my planning and design work, and as well as mistakes, and sometimes those mistakes are just a mistake in judgment because you don't have the exposure. And I really learned a lot, not just from the other engineers I worked with, but also from the operators, the maintenance people, the managers of the different water systems, that then made me both be able to develop great relationships with some of those folks. And you really got to listen, because sometimes when you're interacting with those frontline folks, they're used to things not always going right. And they're not going to right off the bat tell you when something's wrong. You really have to build a relationship, get to know folks, and then they'll start opening up and be honest with you. And sometimes that honesty can sting a little bit when you've maybe not hit the mark for what they are looking for. But if you really listen and build that relationship, you can get some great valuable feedback that makes you a much better engineer and makes you more effective on the next project or the next assignment. So that's really kind of, for me, what's been, I think, the most useful, as well as the most rewarding is seeing the end result of the work I've done.
Yeah, rewarding and seeing the end result, that is obviously the outcome, which makes us all excited about. And here we have Tom. Tom, you started out as an environmental engineer, and you worked for the U.S. Army Corps of Engineers, City of Austin. You were the executive director for Wyoming Valley District Sanitary Authority. And then you taught at Wills University. You were engineering manager at Fort Pennsylvania American Water, and are now a prestigious Bentley Fellow. Obviously a brilliant career. What are some of your highlights?
Okay, looking at the pictures on the screen, I realized that one key to success in engineering is you don't have to be very good looking to be successful. But in any case, that's good for me, because if I had to get by my looks, I'd be in trouble. Okay, yes, thanks for that introduction, Shar. Yes, I've had a broad career, worked with the Army Corps of Engineers initially as both a researcher and working on a variety of projects. I got to work on systems ranging from the New York City water system down to outhouses at Corps of Engineer recreation areas and everything in between. And then I went to Austin, Texas, and I was working in the engineering modeling group there. And then my boss moved over to operations, and she took me with her, and I became manager of distribution system operations, which is just like Steve said, you learn a lot by talking to the operators. Engineers that isolate themselves away from operations miss a lot of that sort of thing. And then I saw there was a job back in the area where I grew up, running the sewer authority, and I said, well, I'll apply for that job. I'll never get it. I'm just, still only in my late 30s. And before I knew it, I was actually running a regional sewer system serving 27 towns. And, it was a pretty interesting job. It was, in some ways, I say the best job I had and the worst job I ever had, because I had a lot of authority, and we straightened out a system that was really messed up and got it working well. But at the same time, I realized I wasn't really cut out to be an executive type person. And that's the thing, you got to find the niche where you fit in. And being an executive director, I had to deal with the regulators and the neighbors and the media, and worst of all, politicians. And I realized that wasn't what I was cut out for. I like to get back to the technical side. So the university in that area was hiring somebody to start their environmental engineering program. And I got to be friends with the chairman of the department, and he said, hired me to run their environmental engineering program. And I was there for 5 years, and I had a lot of fun there, and we got their program accredited. And then I wanted to get back to the real world, and that's where I ran into Steve. And Steve hired me as the engineering manager for the eastern part of Pennsylvania, and had a great time there for a couple of years. I would have still be there, but Hasted Methods and then later Bentley made me an offer I couldn't refuse, and I got into software development, because all along I'd been working in software, and that's really where I had the most fun. So working with Bentley systems now has been great because I've been able to use all that experience I had to hopefully make our products better.
Absolutely,
You,
Tom.
Sean.
I think your contributions to our products demonstrate themselves every day across the globe, and we get such great user testimonials. You certainly help advance water infrastructure, each one of you on the call, Steve and Earl as well. So, and I'm Shar, Director for Water Solutions at Bentley Systems. A little bit about me is I started out as a researcher at the Environmental Research Institute. I moved to engineering support at Hasted Methods, and have held positions in training operations and implementation at Bentley Systems. The highlights for me are the opportunity to train thousands of engineers around the world on water modeling and being able to co-author AWWA's M32 computer modeling book, winning the Distinguished Engineer Award from the University of Connecticut, and delivering a TEDx talk. So I'm excited to learn more about our speakers today, as the rest of you are, and we'll share my thoughts along the way. So back to you, Earl. What made you choose water resources engineering as a career?
Well, like I said, I started with Turner Construction, and it was good. I was out in the field, and I was, doing office administration on a construction site. But the days kind of were long. There was a lot of time where you're just waiting for the next concrete pour, or the steel to go up, and I just wasn't feeling challenged. So I went over to Killam Associates, a consulting engineering firm, to try something new. And I got in there, and we're doing different projects in the water space. At that time, there was a lot of treatment for groundwater, volatile or organic chemicals, and there was always different pump stations and pipeline work that needed to be done to get potable water to folks. But I walked into that room with that mainframe, and I sat down with that computer, and this is back in the day when there was no PC. So we had paper maps, and we had flat, ASCII files where we had to load everything up. And it was like doing a puzzle, because you had the map on paper and the pipe numbers and the node numbers, and you'd have to get that in the computer. And it was interesting because it was like the first digital twins. So we're really trying to get the computer to predict what's going out in the real world. And I just found this puzzle solving to be very interesting. I could pour myself into it. The time went by quickly. It was fun back then, but you would set up this, for the audience here who's much younger and starting their career, they don't, I think, appreciate how slow computers were. So I'm sure some of the folks on the younger folks on the call right now are working with models and stuff, and they push the button and an extended period simulation happens in 8 seconds. Well, we would set up the file to do an extended period simulation to run overnight. And then we would come back, and hopefully the computer hadn't crashed. But it was just challenging, and it was fun. And then the industry in the 90s just really started moving quickly. The computers came along. We moved to the PCs, and you could do more, and we could get in the forefront of things. I remember, using the tools to do things like that are software, that are in the software now, like the T-Rex, to do elevations, or the demand loader. We were doing those. We were hacking it ourselves prior to those being commercially available. So it was all just a lot of fun. And I was like, okay, this is where I belong. And, kind of made a career out of it.
That's quite a story. Obviously, you have evolved your career along with the technology advancements too. That is definitely something very interesting. So Steve, what made you choose water resources engineering?
Yeah, thanks. Well, so my degree was actually in civil engineering, and the program I was in, which was at George Washington University in Washington, D.C., was really robust. It wasn't much in the way of electives in it. There were a lot of required core courses. So I actually had as strong a background educationally in structural engineering, foundation engineering, things like that, as I did in water and wastewater. My program included both tracks quite extensively. So I could have gone either way, actually. But what really made the difference was that I had two opportunities to work in the industry during my college years. First, I worked a summer with a pre-stressed concrete storage tank contractor, a large contractor, and there's only a couple of them in the business, and that was really interesting. But it wasn't as challenging as what I was really looking for. But then I got a chance to work for Camp Dresser McKee, now known as CDM Smith, big environmental consulting firm, and I was doing making drawings, doing specifications to assist the engineers with various water wastewater projects, and I found that really interesting. Then I got a chance to help create a hydraulic model basically from scratch. I mean, we were writing the code. This was before you had, Bentley sewer gems. If we had Bentley sewer gems back then, I wouldn't have had a role in that job. But this was back when, a lot of entities were writing their own programs for modeling, and I really found that challenging. I loved both the computer work. I loved the various design work. It was very interesting, challenging, very varied, gave me a lot of different exposure. And, in just those several assignments during my college years, it really brought me out when I came out with my degree. It just was the place that made sense for me to be, was in water resources engineering.
That's quite a fantastic reason, the why and how you were able to modify your choices and adapt and pick the path that gave you most success. Over to you, Tom.
Okay.
What made you choose water?
Okay.
Go ahead.
I actually started out as a math major, and because I liked math and was very good at it, and so that was going to be my career somehow. But I wanted to do something useful, and at this time, environmental awareness was really becoming important in America, because I grew up in an area that was kind of a coal mining town, a poor town up in the mountains, and we had everything wrong with our environment. The raw sewage went straight into the river. The air quality for the mine fires was just terrible. It just peeled paint off the houses. Garbage disposal, solid waste management consisted of going to this old abandoned strip mining and throwing your garbage into the strip mines for rats to eat it. And so that was kind of the nature of the environment. I said, we've got to be doing a better job with the environment. This was just bad. And so I took my interest in math and the environment and tried to find something that would kind of intersect with them. And one day I was talking to the chairman of the math department, and he says, there's this new stuff coming out called computer modeling. You ought to look into that. And I don't think either one of us knew what computer modeling was, but I did. And it turned out that it was just a perfect match for me. So I went off to graduate school at Vanderbilt and worked on that sort of thing through my school time, and got into my degrees in environmental and water resources engineering. And it's been just great since then. So it just happened to be at the right spot at the right time for me.
Yeah, right time and right spot, right place, as they say. So let's now move on to organizations and industry trends. One of the questions that we got from our audience is, what type of organizations or companies recruit water engineers, and what kind of projects do they typically do? Earl, what do you think?
Well, the types of organizations that recruit would be the water utilities themselves. We've actually seen water utilities hiring more engineers over the years. When I started, a lot of the engineers were in consulting engineering firms like myself, like the one that I work for, Mott McDonald. But more recently, the utilities, the larger utilities, are staffing up with engineers and growing their own engineering departments. So that, that's a great place to work. And I think, as Steve and Tom both said, that's a good place to interface with operators, where you can really learn the business. And then there are the infrastructure consulting firms like mine. There's, a lot of them, and everybody's hiring right now. Let's just, the water industry is, there is a lot going on, between regulation, the needs for more capacity in water, and then the renewal. Everything is getting older and needs to be replaced. So you have, the water utilities themselves, you have the consulting engineering firms like my own, and then you have a lot of the vendors that support the utilities, the vendors that manufacture the pumps and the pipes and the valves and all the equipment that goes into a water utility, whether it's on the water side or the wastewater side. And what's even growing more now is the software side. The water engineering software companies out there like Bentley, but there's a lot of other ones where you can get in there and do all kinds of interesting stuff with a software tool. So those three areas, I would say.
Definitely so many opportunities and so many industries that recruit water engineers because water becomes such an essential part. Steve, what do you think?
Well, I would agree with what Earl just said, but what I'd add to that is I think also both government, some government roles such as regulatory roles and research type roles as well, whether it's an academic research organization or like Tom described, in his career working for the Army Corps of Engineers, Waterways Experimentation Station. It's kind of a government agency, or even these days a lot of NGOs, non-government organizations as well, given kind of the expanded focus on the environment, focus on sustainability. I think those are all drivers that are taking things to another level, and I think opening up a greater variety of opportunities. That being said, though, I still think that the most hands-on and interesting experiences come from working for a purveyor or consulting firm, at least for part of your career, and especially early in your career. And the reason I say that is because it gives you, I've worked with regulators, for example, who have not had experience in consulting or working for a water utility or wastewater utility. And generally, I've found that they don't have an understanding of how things really work, and versus regulators and people in academia who have had those hands-on experience, like Tom. I mean, Tom, like he described, he's gone back and forth between those different types of employers, and those people have a much better understanding of how things actually work, and then they can be effective in either software development, government, research, etc.
Absolutely. And Tom, I'm sure you agree with what Earl and Steve said. Do you see any other types or also projects that they typically do?
No, Earl and Steve told most of what I was going to say, and that's great. The idea, I guess I could add to it, is to make sure you communicate across these groups. Don't just say, well, I'm an engineer and I know more than the operators, so I don't need to talk to them. I mean, a lecture I gave one time was take an operator to lunch. And the idea was there, if you're the engineer and you're working with somebody, become their friends and listen to the operators, because I've dealt in some situations there. I remember one project where I was managing where we had a consultant who was like one of the world's leading experts in that field. And he was saying he was doing his design. We had a design review meeting. And I said, I'd like you to come in and talk to some of the operators about how this thing is going to work. And his answer was, I don't need to talk to the operators. I know how to do this, and I'll tell them how they operate it. And I just was very upset with that. And it turns out when he finally built this thing that he designed, it didn't work very well. We needed to get the operators involved to fix it so that it would work right. So don't be that kind of guy. Just because you have an engineering degree doesn't mean you know everything. And listen to the operators and such. So that's my extra part I could add to what Earl and Steve said.
That's sage advice, Tom. I mean, engineering is teamwork. You not only team up with engineers, but also other roles that complement and work at a water utility, like operators, a field crew, and other departments within the water utility, and also within a consulting firm. So let's move on to some of the exciting and remarkable water projects that you worked on or that you observed that have made a positive impact. Earl?
All right. So when I read this about remarkable water projects, there's just so many projects that I'm not really able to pick whether they're done by myself, my company, or other folks. So what I wrote down is kind of what Tom had said before. If the audience just appreciates how wonderful sanitation is, the beauty of going to your faucet, opening it up and having clean water come out, and being able to take a shower, flush a toilet, and have that waste product leave. Sanitation has many surveys have been performed over the years, and they ask the question, what are the most remarkable things that have happened in terms of public health? And sanitation scores higher than vaccines and different medications or infectious disease control. So I just think the industry that we're in, and there's always work to do, but the ability to continue working globally, we actually have to push this outside of the United States and more of the developed countries, and go help the folks in the other countries that would really, really benefit from just basic sanitation. And I think the younger generation coming up, that's part of, if they have this interest, to get out there and move this forward and help the people who aren't as fortunate as some other people. So that would be my basic take on it.
Oh, sure. Steve?
Yeah, I think Earl's right. I mean, there's just so many things, and I've had many different experiences, and every year brings new experiences in this industry, and it may not have the glitz of certain other these days with the media experiences out there. There's a lot of glitzy careers and directions you can go. So you may not have that, but really what we have though is a constant stream of meaningful work and new experiences. That's what this industry can offer. It certainly offered me that. I'm just going to give one example of a project that we did at American Water. We had acquired several smaller rural utilities in northeastern Pennsylvania. And Tom kind of gave you a backdrop from years before that of what some of the problems were in northeastern Pennsylvania. So this was some years later, but those systems needed major improvements. And my team and I were able to put together a plan, first of all, a plan to create a regional system by interconnecting those acquired systems, figuring out what the synergies were that enabled us to improve the reliability of the water supply to those customers, and to do it with fewer total capital and operating expenses invested. For example, we figured out where was the best places to put water storage and the right amount of water storage that could be shared across the entire system. We had a system of pressure regulating valves, and this is kind of a hilly, somewhat mountainous area. So we had various pressure regulating valves and booster pumping stations to move that water between the various customer zones and to move it in and out of the storage facilities in order to make sure we provided, the daily demand equalization as well as needed firefighting volumes. Now, by sharing the storage, the advantage here was that these were fairly small systems. So the amount of storage needed for firefighting volumes was far greater than the amount needed for demand equalization. And had we put the required amount of storage in each system individually, what we would have done is we would have created some water quality problems because you wouldn't be able to turn over the tank volume frequently enough, and that water would have gotten stale. You would have had low chlorine residual. So by looking at the problem holistically and coming up with the right mix of projects, we not only saved money, but we actually created a more reliable system with lesser problems. The other thing the big thing we accomplished with that is we improved the supply reliability. They would have outages at times because a well would fail. Well, what we ended up doing was we took the best wells from each system, we kept those wells, we interconnected the systems, and now if any one of those wells failed, it didn't take the system down because we had the other wells from the other systems that were able to feed any of the customers. And we ended up with a fewer number of wells, but better wells and more reliability. So that's just an example of the kind of project. And that gives you a lot of satisfaction to know that you went from having customers who would have outages and all the problems that go with that to having a system that rarely, if ever, failed.
That's quite a impact that you made, right? Having that reliable delivery and waking up every day knowing that you're making a positive impact by providing clean drinking water to people. Tom, obviously you've worked in a lot of water projects, and you also see a lot of them, being shared with you. What are some of the highlights in terms of projects that stood out?
Well, I've worked on a lot of projects, but also I like to think about the contributions I made to the state of the practice. What are best practices in some engineering? So let's just talk about mathematical modeling of water and sewer systems and such. When I started doing it, there was really no practice for making sure your hydraulic models, your computer model of a system, really behaved like the real world. I mean, the idea of model calibration was, well, you'd go out there and check a pressure at some fire hydrant. If it was close, it was okay. And I realized that that's not why you make these models. You make these models to simulate fires and outages and emergencies and this sort of thing. And we weren't testing them. So I started using fire hydrant flow tests as a way to stress the system so that it would reflect not just average day conditions, but those bad conditions, which is what you designed for. And that really started me working on model calibration as an art and science itself. And so we started recommending doing hydrant flow test as a way to stress the system and test the models to make sure they really reflected it. And with the coming of better integration between the computers where the modeling was done on and SCADA systems or other kind of telemetry to bring in field data, we can do a much better job now making sure that the model really behaves like the real world, because that's what the model is. One of the stories I say is that, what's a model? Well, a model is kind of a cheap imitation of the real world. I mean, so, in some cases you have a model train that's a little train that runs around the tracks, and that's a model of the real train. Or you have a model car. It's a little cheap imitation of a real car. And I call myself, and my wife calls me a model husband because I'm a cheap imitation of a real husband. And so models need to reflect what's really going on in the world. And I think that my work in that has been, has really changed the state of the art. And we just are working on a book. I'm on a committee with AWWA, the American Water Works Association. We're coming out with a handbook for model calibration. And I think I've ended up writing half the handbook. It was supposed to be a committee job, and it kept being, well, so-and-so can't write his chapter, Tom. Will you write this chapter too? And will you write this one? So I've written about half that book, and it's going to be coming out this year. And it's really kind of a culmination of a lifetime of work in this area. And I'm kind of really proud of that kind of thing. So it's not just doing the projects, but also advancing the state of the art by your work.
That is awesome, Tom. So for those of you on the call, right? I mean, what Tom has done is a long time ago, you used to have computer models that were ideal, right? And sometimes they may not match what they're seeing in the real world. But by doing this calibration that Tom's talking about is taking the real world results and putting it into the computer to make it smarter and smarter trained, and taking advantage of all these advancements that we have in the industry now, like smart devices, and being able to take these accurate measurements. What you see on the screen is what is in the real world. And before any utility spends any money, right, before they go dig and spend a few $1,000,000 constructing an entire pipeline, and doing that, they can try different combinations, right, scenarios and alternative to see. It's not always the most expensive solution, but rather the most optimum solution, right? So you're able to do that. And when an emergency happens, right? For example, there may be a fire event, or you may have a water shortage. Being able to predict it before it happens and being able to plan for it, and when it really happens, your computer has already given you those answers, and you've already prepared your city, and suddenly all the engineers can feel so good because we have predicted reality based on engineering facts, right? So I think making that computer model close to reality is a pretty big positive impact. And thank you, Tom, for being one of the key contributors to that one. I think you've definitely advanced the field. I also see Bentley recognizing remarkable water projects, right? So every year we welcome the best of projects from all over the world to submit the advancements they've made in Going Digital infrastructure event that we have every year. If you Google Year in Infrastructure book, you will see that we have hundreds of projects being submitted for over a decade now on all categories, right? Water and wastewater distribution networks, water distribution networks and wastewater collection systems, and also water and wastewater treatment plants. And you're able to see the impact that they're making, right? In terms of money saved, time saved, lives improved, the pressure that they've improved, and also how much time has been saved in all these projects just is tremendous, because they've used all these models to improve and optimize their system. So do take a look. There's like hundreds of projects that you can learn from, and that's what is really satisfying. So I just want to move on to the innovations, right? Obviously, Earl, Steve, and Tom have seen a lot of innovations. And it's also something that our audience is curious about. Are you seeing any trends around sustainability and environmental benefits and innovations in the industry?
Guess you're gonna start with me again, Shar?
Yeah, absolutely, Earl. You first.
Okay, so there's a lot of innovations in the water industry. I mean, there's just so much going on, and I'm just gonna hit a few bullet points here without getting into anything in much detail. Machine learning and artificial intelligence. I think this, Tom has said repeatedly that the brain is still the best computer, but it doesn't, machine learning applied with some discipline can see things that we might just miss because of the amount of data. So that this is ongoing. Mott McDonald, we recently used a lot of machine learning to try to figure out, in the United States, we had the lead service line crisis. So we've been going into different cities and helping them try to understand, based on all kinds of data sets, where these lead service lines may exist, so that you might save a little money and not waste as much time trying to get to the answers there. So that is definitely an area, it's a little interesting because you really need, there's the digital element. A lot of the younger generation can code in Python and do all this stuff, but you do still need the mentorship. So you have to, get the domain knowledge from the people who have been around. So, you're applying the machine learning in the right way. So that's just one bullet. And then I'll just hit a couple others here real quick. There's always advancements in treating water and wastewater. Looking to invent, a better mousetrap. There's advancements that are driving down the costs to do things like, desalinate water. It's very expensive to get salt out of water right now, but it is probably our future. But until we can not pour a bunch of carbon into getting the salt out of the water, it's going to be an area that's still going to require a lot of, thinking and input. So I see that happening. And then on the flip side, on the water conservation side, if we use less water or we use water more efficiently, the whole equation gets more balanced. So, if you're going to have a lawn, there's probably better ways to water your lawn. We've already seen advances in water conservation, shower fixtures and toilets and that's part of the balance that we play nice with our ecosystem. Manufacturing, people are making equipment that lasts longer, it's more durable. This will go into the life cycle costs. You might spend a little bit more money up front, but you're going to put something in the ground now that might last 150 years instead of 80 years, just pipes. In the United States, the amount of pipeline that is going to have to be replaced in the next 25 years is staggering. And if we can find better materials, better coatings, better protection, understand where we're installing these things, the folks who are manufacturing these products are putting a lot of time and effort into making sure that the things last longer. And then I have digital twins here. We've talked about that already today. That's going to continue to be a place where you have a sandbox to play in, which is replicates your system. So if you make a mistake here, it's not a big deal. You just reboot the computer. If you make the mistake out here in the real world, it could have a lot of bad consequences. So that's my quick spiel on that.
You touched on a lot of important trends there. Desalination, obviously, it's in the news every day from California. We also have a lot of people from Middle East in the audience today. So, they're definitely converting a lot of salt water into pure water that is potable. Just amazing innovations there. And you also talk about, all these smart devices and digital twins, AI, predictive analytics. That's the beauty of water industry now, right? We're able to not only leverage the water industry, but also take advantage of the latest advancements in electronics and computer science and bring it all together into something that actually serves a purpose as basic as drinking water. So over to you, Steve. What are you saying?
Earl hit some great points. I think a key area that's been growing for a number of years, several decades now, but I think will continue to grow is just asset management. And Earl mentioned life cycle costs. I think that's an important component. And as the systems that we have for data management and analysis continue to improve, things like GIS, that's again been around for a long time, but it's really developed over the years. GIS, SCADA, which are basically your control systems for your water, wastewater utilities, maintenance management. As all of those things continue to improve, it gives us a more and better information to make decisions about life cycle cost for assets. So, for example, when you're sizing or selecting a pump in the water industry, over 85% of that cost, and it's probably actually higher now as energy costs have gone up, but over 85% of the life cycle cost of a pump is the energy cost. About 10% is maintenance, and about 5% is the actual initial capital cost of the pump. So, you need to bear that in mind when you're making a decision about the efficiency of a pump, and not just the mechanical and electrical efficiency of the pump, but how you're selecting the pump to meet the various operating conditions that are required. And a lot of times what happens is I've seen a very efficient pump selected, but it's not selected for the right application, and therefore it doesn't operate efficiently. It's capable of operating efficiently, but it's not operating at its correct point. So those are the kinds of things that can make a big difference. And digital twins has been mentioned. I just want to tack on something to that. I think that's a great tool that is taking automation and information technology to the next level, because it can now branch over to be used as a tool by operations personnel, not just a tool for engineers to do analysis, but operations people to actually look at things real time. But one of the big remaining challenges for most utilities is data availability and accuracy, and that can limit the good decision making. So I think that's an area that I see a big need is to how can we collect data and make sure it's accurate and do it more effectively, so that the computer systems we're using for artificial intelligence and other decision making can actually be more effective.
That's very thoughtful, Steve. You hit up on two key points, in my opinion. One is obviously the pump energy, which obviously everyone cares about on this call, reducing carbon footprint, and therefore, not only supplying water, but being environmentally conscious. The other thing was, digital twins and having access to all the smart data, and then the need for data analytics and data quality. One thing that I'm seeing water engineers do more and more is specialize in additional things, right? So if they wanted to go into data management or data analytics, they can definitely take that data, make sure that all of these disparate systems, because data exists in so many places, right? In GIS, like you said, in SCADA systems, and also it could be within this vendor databases. And we're all able, and also hydraulic models. So we're able to bring it all together in terms of a digital twin and see the whole city at the same time, right? So you can see, your water system, wastewater system, your stormwater system, your electric utility, the roads, bridges, buildings, and are able to see all of that on a nice map and get real-time information, right? All these smart devices are giving you, hey, this is the flow happening, this is the pressure happening. They can measure water quality, and make sure that all the sensors are calibrated. There's no alerts that are saying it's out of range, and being able to then pinpoint, okay, what could be causing it? Is it a hardware issue, or is it data cleanup, or is it something where the field crew can go and test what's happening, right? So being able to be in the cutting edge of the industry is another exciting opportunity that we are seeing as a trend, while benefiting the environment too. So Tom, what are you seeing as trends?
Okay, well, thanks again. You guys have stolen everything I was going to say, as you have all along.
Tom, you can go next time to first. We'll start with you.
That's okay. Yeah, that's okay. I can handle it. One of the things is, though, I'll just leave you a little analogy about digital twins. I mean, we have some great technologies out there. As everyone said, we have GIS, we have asset management, we have computer maintenance systems, we have SCADA systems, we have artificial intelligence, hydraulic modeling. And I think of these, in the past, these things have been like children locked in their room. The asset management people are locked in their room, and the kids doing GIS are locked in their room, and the SCADA kids are locked in their room. And what digital twins have done is unlock the doors and let these kids play together. And they're having a lot more fun now that they can all play together. The GIS guys could play with the asset management guys who could play with the hydraulic modeling guys. And that's I think one way I could look at and leave you with a message to think about digital twins.
Awesome. So Tom, next question is on job opportunity and career advice. So, Yeah, well, what advice would you give to someone interested in a career in the water industry? What's the advice that you think will help them get started?
Gee, that was one of the ones I wasn't ready to answer. Okay.
So I'll
No,
answer it, right?
I think its idea is to be ready for your career. Get involved, get an internship if you can, join the professional society like American Water Works Association, Water Environment Federation, International Water Association. Student memberships in those organizations are really inexpensive, and they give you a lot of information about the industry beyond what you get in classrooms. And if you can get to a conference, if there's some conference close by that you can drive to, you don't have to incur a lot of expenses. Student registration at conferences is really inexpensive, and you can see so much. I remember the first time I went to National American Water Works Association conference, it was just blown away by the exhibit hall. All this equipment is fantastic. And so don't just go to school and expect that the day you graduate you're going to get a job. You got to get yourself out there, get on committees. There's young professionals and student subgroups within these different professional societies. Get involved with that kind of thing and make contacts outside. Don't just just go to class, get involved with the profession and plan to be a professional.
Thank you, Tom. Over to you, Earl.
Advice for folks?
Advice for someone getting started in the water industry or someone interested in a career in the water industry.
Yeah, so let's say you've got to the point where you've, like Tom says, you've joined some organizations and you've seen some things. At that point, pick a direction and just and go for it. For me, I'm in infrastructure consulting in water, and I think it's great. But you could go anywhere and try it, and you can always change your mind. But I think do your homework, see what you like, see what you might get your juices flowing, get you passionate, and then give it a shot. It may be exactly what you're looking for, and it might not, but you can just pick another direction inside the industry. And if you feel that this is a good place for you, you'll find something.
Yeah. Steve?
Yeah, I think Tom and Earl have really given you some great examples of things you can do early in your career, even while you're still a student. Earlier I gave the example that I had of having an internship co-op work experience and what value that gave me, both in terms of making sure it was the right field for me, but also putting me at a great advantage when competing for a position when I graduated, because I already had very practical and tangible experience that employers could leverage right away. And not only in getting a position at the beginning, but that also served me well as a solid base that I was able to build upon every step of my career. But I think the most important thing, and all the things Earl and Tom mentioned, as well as what I have, I think the most important thing is that you constantly and continuously seek new knowledge and new experiences. How you do this doesn't really matter exactly. I mean, do what works for you, whether it's attending conferences, getting an internship, joining professional organizations, getting on a committee. All of those things are great things, and you can't necessarily do them all. And depending on your personality and what interests you, which of those things you get the most benefit from and the most enjoyment from will vary. And so just get out there and start doing those things, and you'll see what works for you, and you'll see what benefits. I mean, really, I think the most important thing is, I view that I have over 35 years of experience, but there's a big difference between having 35 years of varied experiences as opposed to having 1 year of experience repeated 35 times. And so I'll leave you with that thought: is strive to have 35 years or 40 years, whatever number of years you end up spending in the industry, having that many years of varied experiences, can be seeking new knowledge and experiences, rather than getting good at one thing in a short period of time and then repeating that forever. Now, of course, we all repeat some aspects of what we do, but what I'm imploring you to do is to really, get out there and learn as much about the industry as you can, and it will make you better at everything you do. So.
No, well said, Steve. Having that varied experiences and being a lifelong learner. One thing that has always fascinated me is when I'm looking for a career in the water industry, there are so many people, right? Obviously, we have 3 very seasoned professionals on the call today. But if you go to LinkedIn, you will see many other water professionals as well. And within each of their profiles, if you take a minute to learn about them, you will see what associations that they belong to, what degrees and certifications that they got, what awards they got, what are the LinkedIn groups that they belong to, and join those groups and see the career path that they have taken for whatever title that you may be interested in, right? And you'll find some patterns and some interesting knowledge and things that you didn't know about before, right? It could be all these associations and awards that they won too, right? So definitely use LinkedIn as a resource. What are some of the typical opening job opportunities for new graduates that you see in terms of titles? What are the jobs that some of these students should be applying or looking for, Earl, when they're beginning their career?
Yeah, man, this industry is just so wide open. Like you said, you can go to LinkedIn and you get to know some folks, but I work in the consulting engineering space. I'm with Mott McDonald as an example, and you can go to infrastructure consulting web pages, and you can go straight to the job opportunities, and you'll just see a list, all over the world, and everyone's hiring right now. There are not enough engineers, honestly, in this space right now to tackle everything that needs to be done. So I don't have any specific opportunities. Just get in there and find something and try it. For me, I think, having a varied career is nice. The way that I did it is I got into a niche in the modeling and the GIS. I built that up and, created a team, and, it started, my team actually knows more than I do now. And then I, once I built that up and I had some success and, some career advancement because of that, that gave me an opportunity to then try something new. But when you get something into one space and you can pour yourself into that, you might want to spend a little time there to, become a master almost. And then when you can hand that off, then maybe tackle another area. So that just some thoughts there.
Definitely good thoughts there. Steve, what do you think are some interesting opening job titles?
Yeah, I think that's one of the challenges in the industry, is that I think job titles are so varied and sometimes misleading. So obviously, if you're in the engineering space, you got to look for the word engineer, but that can be used in other jobs as well. But I think environmental engineer sometimes is used, project engineer, usually entry to mid-level roles to look for if you're doing a search. Sometimes don't get too hung up on the job title, though. I think look at the description of what it does. Does it sound interesting? And I think the other thing, I think Earl hit on this as well, which is important, is when you first start out, there might be some aspects of what the job entails that may not seem the most exciting or the most, you might feel like, oh, well, I've got much more capability than this. And you probably do. I think you've got to build that foundation. As Earl said, you have to master it. So don't take what I was saying earlier about, varied experiences. Don't take that as not concentrating and mastering something. No, that's not what I'm saying. What I'm saying is get out there, experience new things, learn new things, but you have to master those things before you move on, as Earl was describing, but continue to grow and continue to add capability. So I think you got to just get out there and look.
Yeah. And Tom, if you'd like to add anything, I also wanted to cover, what are some of the websites that you recommend, association magazines that you would recommend to students to learn more about this field?
Yeah, figure out which branch of the field you want to get into and join that organization. I was going to say something though on careers though, is you don't necessarily have to follow the pack. You got to look for what's going to be the next big thing. So when I was in graduate school, all the money was going to construction grants program. The EPA was paying for utilities to build sewage plants, and everybody it was in grad school with me went into wastewater treatment. And because that was where the money was at that time. And I was starting to hear about this stuff about infrastructure and aging infrastructure as being important. So while everybody else was going to wastewater treatment, I went into the hydraulics, the collection systems and distribution systems. And then when the construction grant money was all spent, I was kind of in a better position because I was looking at the next thing that was coming down the pipe rather than what everybody was hiring people for at that time. So that's something to also think about. It's okay to be a little bit of a contrarian sometimes.
Early,
Yes,
yeah,
as far as
Go ahead. Go ahead.
Well, I was going to say, as far as organizations, figure out which of the organizations suit you the best, which ones have activities for students, and it's a good way to get started. And you'll get a magazine from that organization, and you get the access to their website, and get access to their training materials, and pursue a PE, whether it's whatever it's called in your country. There is usually some type of professional licensing. To be in the U.S., it's called a professional engineer, and there are other names in other parts of the world. But get that license. That license is probably, if you look at the difference in salary over the length of your career, it's probably worth about $1 million in extra income over the next 40 years if you get that professional engineering license. So make sure you get that certification. It really is a valuable thing.
Thank you, Tom. We are right on time, but be sure to visit the Bentley Education Portal. The link is going to be in the chat box. Students and educators now have complimentary access to Bentley software that's used by companies around the world to create amazing water infrastructure projects. So it has all the resources you need to have an exciting career. So I strongly recommend joining the Bentley Education Program. I thank you for joining us, to all the attendees and also the speakers who have taken time from their busy day and given us so much insightful information. We will do this again. Thank you.